In this last example here, we want to find the coefficient of a cubed b squared in the expansion of this binomial 3a plus b to the fifth power. And this is where it gets kind of tricky because I'm looking for the coefficient. So that just means I'm looking for the number that's in front of a cubed b squared. This is what my answer should be, this thing. And how do I find that? Well, I could spend the time to multiply 3a plus b out over and over and over again, or I can use the binomial expansion properties that I've seen so far using Pascal's triangle and all those properties with descending and ascending exponents to kind of hone in or narrow in my focus on just that coefficient of this term. So let me show you what I mean. If I recall what the typical expansion is of a plus b to the fifth power, that's going to be equal to a to the fifth plus 5 a to the fourth b plus 10 a to the third b squared plus 10 a squared b to the third plus 5 a b to the fourth plus b to the fifth. So that's my typical binomial expansion. Again, look at the coefficients. It's Pascal's triangle, fifth row, and the powers all follow that properties that we were talking about in a couple of videos ago. So if I know that my a is the first term, a equals 3a, excuse me, and the b is the second term, b equals b, that's kind of convenient. If I'm looking for when this is a cubed b squared, we kind of think, well, how am I going to combine this 3a and this b in order to get an a cubed and a b squared? And hopefully you're seeing that all I need to do is if I were to cube 3a, then I would get an a cubed, and if I were to square a b, I'd end up getting a b squared. Now that might seem kind of trivial, but you won't always get such nice and easy a's and b's like this. You might get a 3 over a, or you might get a b to the second power. And in that case, we're not looking necessarily just for the a cubed b squared term, but we have to think about how you make these a's and b's, the actual terms, get you to a cubed b squared. In this case, it works out nicely because it means that I'm looking for whichever term is cubing the a and squaring the b, and that looks like it's going to be this one, cubing the a and squaring the b. So now I don't need to find the entire expansion, I just care about this term right here. So this is going to be equal to 10 times a cubed, and a in this case is 3a, that's cubed, times b, which is b, squared. And this is going to equal 10 times 9, I'm sorry, that's cubed. So that would be 10 times, that's a 3, 27 a cubed times b squared, and that'll equal 270 a cubed b squared. This is the term in the expansion of this binomial to the fifth power with the a cubed b squared. I can't remember how the sentence started. That was a long sentence. Basically what I'm trying to say is this is the coefficient I'm interested in because it has the powers a cubed and b squared a part of it. So the answer here, the coefficient, is 270, and that's it. So why don't you try this example here, very similar, same type of a style. This is now being raised to the sixth power, so a little bit different, but you know how to do this. Look at Pascal's triangle and give it a shot. All right, so here's my work for this one. Pause the video if you need to look over it and see if it matches with what you did, and hopefully you're able to get it.